So, hello, I'm here with Dr. Pradeep Natarajan, this year's Jeffrey Haig Award winner for extraordinary contributions to atherosclerosis and vascular biology here at the Vascular Discovery meeting. So, welcome, Dr. Natarajan, and we're so thrilled to have you. And your work has obviously been just so amazing to watch over the last few years. It's really accelerating, the genetics of cardiovascular risk and understanding all the ways that our genes are contributing in potentially ways that we don't know, right? And quantifying that. So tell us a little bit about that.
Yeah, Dr. Rayner, thank you so much. I'm super excited to be at this meeting and immensely honored to receive this award. The ATVB meeting was the first scientific meeting I'd ever attended. That was about 14, 15 years ago. At that time, also working on atherosclerosis and lipids. And the tools to study atherosclerosis, particularly directly in the target human, have evolved substantially since those past 14 years. My focus now has largely been using human genetics because the technology has evolved, the ability to scale the technologies to profile such molecular features at the population scale have evolved. So I still work on lipids and atherosclerosis, but now have been exciting to use those tools to also look at novel mechanisms for atherosclerosis that are not directly related to lipids. A number of years ago, we repurposed the genetic data that we use to look at the germline genetic contribution to lipids and athero to now look at somatic mutations. What was surprising, and this was a coalescence of a bunch of different studies in about 2014, as we were generating more population level whole exome sequence data from blood DNA, we and others found that actually many of those individuals had acquired somatic mutations that were pathogenic that are seen in patients with leukemias. And it was way more common than anyone would have anticipated, such that individuals in their 70s who were asymptomatic, about 1 in 10 had them. So not only did they have a mutation, it was expanded. So there was some selection for fitness, but none of them had blood cancers, no other clinical abnormalities. They obviously had a high future risk for blood cancer. There was an increased risk for death by about 40%. But blood cancer is still pretty uncommon, and actually cause-specific analyses lent itself to the hypothesis that it may be related to the most common cause of death, coronary artery disease or atherosclerotic cardiovascular disease. And so we followed that up a few years later with multiple lines of evidence in support of this phenomenon termed clonal hematopoiesis of indeterminate potential as being an important contributor to future atherosclerotic cardiovascular disease events. That was using multiple human data sets and some murine work as well too. And now since then, murine work and then additional human genetic evidence has tried to pinpoint the actual pathways that seem to connect clonal hematopoiesis and atherosclerotic cardiovascular disease. And it's an exciting time because, we have used the same about 5 or 6 modifiable risk factors to prevent atherosclerotic cardiovascular disease for the last half century. And we as a field continue to identify biomarkers that help refine risk, but we're still treating the same modifiable risk factors. So now the preclinical data here, suggests that this could be a new risk factor, and there may be something entirely different that you would do in this context, and really advancing these notions of precision medicine. And that's, also exciting to me as a preventive cardiologist.
Right. And I think that, that last statement where you said precision medicine is so key to how we're going to be moving forward as a field. And we've heard a lot at this meeting, this sort of, this residual risk, people call it, right? So we're doing all the best thing for patients with coronary disease or other vascular diseases, and yet still there's more to be done. So, and yesterday you participated in the pro-con debate about genetic risk score, sort of in clinical practice. And so I guess it's still debated, right? If we should be adding this to our arsenal of the way that we understand risk in individuals for coronary disease. So was the debate, it seemed like it was a pretty hot debate.
Yeah. I think, regardless of how we approach residual risk, it's obvious that coronary artery disease remains the leading killer in the U.S. and now over the last 2 decades has been the leading killer across the world. And so we need some major changes in paradigms, and there's, I think, multiple different ways that one could go about doing it. And the approach that we've taken to identify patients at risk has largely also been the same for like the last half century.
Mm-hmm.
And so not only do we need new models in precision medicine, new risk factors, identifying new causal risk factors that you would treat differently, but also rethink how we identify risk. And part of the notion, as we all have, I think increasingly appreciated, that atherosclerosis starts early, longitudinal exposures magnify future risk.
Right.
So better identifying folks early in life remains a major scientific goal. And the approach that we take now for 10-year risk is great for identifying folks at middle age. But we know that the exposures start early, athero starts early. So how do we identify folks early on? The way that we do it today, or have done it for a long time, is just with blood lipids.
Mm-hmm.
Now, polygenic risk scores provide a complementary model for risk identification, complementary to the conventional risk factors. But what's unique about this biomarker compared to others is that that information is static throughout life. Its
Right.
contribution to risk does change throughout life,
Right.
but its effects seem to be the largest when ascertained early in life. And the model seems to be very similar to lipids. And it
Right.
also seems to be a modifiable risk factor, meaning lifestyle modification, statins, and other strategies may also reduce future risk. And when you identify risk early and you start these therapies early, these are the folks that will benefit the most lifelong.
Right.
So I think there will be a model going forward. It is also, I think, not an esoteric biomarker anymore, because increasingly so companies that are doing direct-to-consumer genetic testing are returning this information. There are many now NIH-funded studies of returning this information to patients within healthcare-associated biobanks.
Mm.
So it's getting out there. And the question is there sufficient evidence to incorporate responsibly based on what we know? What is the additional evidence that's needed? So it's an interesting time point where still, everything is largely observational,
Right.
but we are incrementally getting it into the clinic, and we need to understand how best we can use this information.
That's amazing. So congratulations again on your award. We're so excited to have you here in Seattle. And we're just, the work you're doing is really straddling all the different fields that are here at the meeting. So we have, people from the Precision Medicine and Genomic Precision Medicine Council. We have the ATVB Council. We have the PBD Council. So we're, it's wonderful for investigators like you to be here that really are spanning, excuse me, all of those councils. So congratulations again.
Thanks.
See you at the meeting.
Thank you so much.